Welcome back to the Flex Diet Podcast. I'm your host, Dr. Mike T. Nelson. On this podcast, we talk about all things to increase muscle, increase performance, improve body composition, do all of it within a flexible framework without destroying your health. On the podcast today, we've got Dr. Cas Fuchs. He's an assistant professor in the Department of Human Biology at Maastricht University over in the Netherlands. He conducts research on the intersection of exercise physiology, nutrition, muscle metabolism, and recovery. And what he's really known for is a lot of cold water immersion, in addition to everything from carbohydrate intake to protein metabolism and a lot more. So today we're primarily talking about the effects of cold water immersion. Does it really kill all your muscular gains? If so, by how much? Does it really improve recovery? What are some of the pros of it and what are some of the cons? Even if you don't use cold water immersion, I think you'll find this interesting in terms of some of the mechanisms that we talk about, different ways you can potentially enhance your recovery. Podcast today is brought to you by myself and my newsletter. If you want to hop on the Fitness Insider newsletter, go to MikeTNelson.com newsletter, and you'll be able to hop on there for free. I've got daily content going out to you there. Also want to make you aware that the Flex Diet Cert will open February 9th, 2026. So mark your calendars, coming up soon. It'll be open for 1 week, February 9th through February 16th. So the best place to find all the information is to hop on to the newsletter. I'll have a bunch more information coming out there very soon. So pretty short today, and enjoy this podcast with Dr. Fuchs, all about the effects of cold water immersion. Welcome to the podcast. Thank you so much for being here.
Happy to be here. Thanks, Mike.
Yeah, I guess we have to thank our friend DC or Dr. David Church for the intro. I'm sorry you know him. No, I'm just kidding.
No, you should be sorry that I know. Good guy. I like him a lot. So
he's awesome. He has always the best referrals too for the podcast too, because he'll be like, "Oh, you have to have this person." I'm like, "Done." Like whatever you recommend, like I trust you. So, and it was funny, he mentioned your name, and I was like, "Oh, that's awesome," because you were on my list when I did the physiologic flexibility certification. I cited some of the studies you had done in relation to cold water immersion, which I still think some of the studies you did are really interesting there. What made you even look at cold water immersion? Because it wasn't like you just published this study yesterday. It's been out for a while, and you were definitely ahead of the trend if you figure out when you had to start conceiving the study, do the study, get it published, all that kind of fun stuff.
Yeah, so the cooling thing, of course, one of the main reasons to study it is because I'm really interested in recovery strategies. And of course, one of the main recovery strategies you would see online and with athletes is cold water immersion, or these cryo chambers or cryosaunas these days. So basically cooling. And the main question is a little bit like, people say, okay, it's good for recovery. At least it's good for muscle recovery. That's what you always hear. Even if you talk to athletes who use cooling, they say like, it's good for my muscle recovery. And, if you really look more deep into the physiology, you're like, maybe, but is it really that good? Because if you really look like, how does that work? At least I had some question marks on that. And also not just me, like I know more scientists, and also with my professor, I discussed this in the past. Even like before I did my study, there was some work from Australia, for example, where they also saw that if you do long-term cold water immersion, so for 12 weeks after resistance training, that they found that you still see gains in terms of muscle mass and strength, but not as much as if you would not do the cooling. So it kind of seems to be this thing of like, hey, maybe it's not good for everything in terms of recovery and or adaptation. So we were like, okay, thinking about cooling, the physiological response, we see a drop in muscle temperature. That's maybe not exactly that good, at least not always, because that's something you actually want to maybe have a little bit higher after exercise for optimal enzyme activity, etc. And also the vasoconstriction that you get. So basically following exercise, we always, of course, ingest our meals to kind of use our meals as a recovery way. And if you lower the ability to get those nutrients delivered by the muscle cell, it could actually impair the recovery process. And so kind of those two mechanisms were interesting to us to see like, hey, let's see what happens in terms of muscle protein synthesis, which is important for recovery as well as muscle adaptation.
Repeat that part again. You froze for just a sec. You said those are interesting because...
Oh, sorry. So was it about the temperature and the delivery?
Yeah, you said we want to keep temperature a little bit higher afterwards, and this helps with recovery, and then it lost you for a few minutes there, or a few seconds.
They say it again. So yeah, you basically have the increase in muscle temperature following exercises is important for enzyme activity, for recovery processes and adaptation. And also the delivery of nutrients, right? So after exercise, we eat meals. The meals will be used, for example, replenishing glycogen. I think also something we may discuss later, but also to provide amino acids to stimulate muscle protein synthesis, which is important for both muscle recovery as well as adaptations. And so we wanted to really focus on that specific aspect to see like, okay, so if we do cold water immersion after exercise, what really happens on muscle protein synthesis? And kind of in line with the expectations, we found that you indeed impair your ability of stimulating muscle protein synthesis compared to if you would not do cooling. So you kind of are not in the most, let's say, it's not the best environment for the muscle if you do the cooling, at least from a perspective of stimulating muscle protein synthesis. So I think the cool thing about that is, at least I find, is that it's very context dependent, and we should not always say like, hey, let's do this recovery strategy because it's good for muscle recovery. I think it's really important to figure out what's the goal of the recovery, what do we want to even recover, and based on that you can decide if it's a good strategy. And again, with cooling, there may be some reasons to do it still, but also certainly some reasons not to do it depending on the goal of your recovery.
Yeah. And for listeners, obviously, muscle protein synthesis, we'll link to some other podcasts. We've talked about that too. You're just kind of taking the amino acids and stuffing them back into muscle tissue to make it bigger and stronger, which I know that's a vast oversimplification of the process, but and then, yeah. And talk a little bit about the parameters of that study, because I think that's where people go a little bit crazy. They hear that, which is a correct synopsis of the conclusion, but then they're like, oh my gosh, if you did it 4 hours after training for 30 seconds, you're destroying all your gains. And it just seems to be like everything online gets taken to the extreme without looking at, oh, okay, well, what were the parameters of which this was done? If you want to talk a little bit about that.
Yeah, sure. People always want a black and white answer, right? And it never.
Yeah, it's good or bad. Tell me if cold water is good or bad.
Exactly. Do I see that doing or not? Yeah. So yeah, in this study, what we did, resistance exercise, one session. At least we actually have an acute study and a more longer term study. I'll explain that in a bit. But the acute study design was one session of resistance training of the lower body, so the legs, mostly focused on the quad muscles. And then following that, we actually put one leg in cold water for 20 minutes. And the water temperature was in degrees Celsius. I think, Mike, you guys use Fahrenheit. I actually don't know the conversion, but that's okay. Like 8 degrees Celsius.
Yeah, I think it's like 47, 48 Fahrenheit, somewhere in there. Someone will correct me online and send me hate mail, but we'll figure it out.
People can look it up. So 8 degrees Celsius, so pretty cold, of course. And the other leg we put also in water. So we kind of had both legs in water to keep that consistent, but that temperature was 30 degrees Celsius, which from like, let's say a water perspective gives you like a bit of in the area of thermoneutral water. Yep. Of course, 30 degrees outside feels warm, but if you're in water, it's actually, let's say, comfortable. And in that leg, we actually also didn't really see much changing in things like muscle temperature. So kind of, it was a nice control leg. What we then did, we measured for 5 hours following the cooling intervention. And immediately after the water immersion, we provided a protein shake, which actually also contains some carbohydrates. So basically like a recovery shake, you typically see that people ingest in the field or in practice. And that contained also specifically labeled protein. And what I mean with that is that we labeled the protein in such a way that we could really see how much of the amino acids that were coming from the protein were being used and incorporated into new muscle tissue. That's a technique that we use here in Maastricht a lot. And so the cool thing about that was that we could not only just measure over these 5 hours in recovery muscle protein synthesis, but we could also see how much of what you eat will actually be used by the muscle to incorporate into making new muscle proteins. And on both those aspects, to make it simple, we saw like that's the protein synthetic response. So that muscle protein synthesis in the cold leg was lower compared to the, let's say, thermoneutral leg. So again, you impair that ability to increase, or like you impair the ability for protein synthesis compared to a control condition. And also we saw that less of the amino acids that you ingest were being used by the leg that was cooled compared to the non-cooled leg. So you also can actually use less of what you eat in these first hours after recovery. Now, you said very correctly, it's always important to look into the context. And this was, again, doing it immediately after exercise, also for 20 minutes and also pretty cold. So, of course, from a scientific point of view, for us, important to get like quite a strong stimulus to see if there would be something. Because, you know, if you do like if you only do it for a minute and like I said, 15 degrees Celsius, you know, and you don't see anything, and you still don't know if there is something going on if you do it like in like a more, let's say, stretching the practical duration as well as temperature. So it was still practical, but it was, let's say, quite relatively long and relatively cold. If you would, and many people like after that study also said like, yeah, what if you do it like 4 hours later? And you know, that's always dependent on how long you do it for, what's the temperature. But I still think this study nicely shows that if you cool the muscle and you reduce your muscle temperature, we also see with recent studies that you indeed reduce your ability to deliver the amino acids to your muscle cells. It's not necessarily beneficial for your recovery. And maybe to add on that, like the longer term study that we did as well, to also see like, hey, it's nice that we see it in the first 5 hours, but what if we repeat this for 7 sessions over a 2-week period? So we followed this up with 2 weeks, by which we use a different tracer technique. It's called the heavy water D2O. And what we could do with that is we could have those 7 exercise sessions over the 2-week period. After every session, we did exactly the same. So 1 leg in cold water, 1 leg in thermoneutral water. And then we again found that over those 2 weeks that the protein synthetic response in the cold leg was lower than the control leg. So it does also translate in the longer term, which also makes sense if you think back about what I said completely at the start, that Australia study we did for 12 weeks, and they with MRI scans, so the gold standard to look at muscle mass and muscle volume, they found also lower gains. So it kind of all nicely lines up, which is definitely not always the case in science, but this really was a nice addition to each other to look into the mechanisms on that.
Awesome. And the 2-week study, if I remember it, that was the same parameters as you used before, right? The 20 minutes around the same temperature, everything else, correct?
Exactly, even the same participants. So it's kind of the extension of the acute study. We did it together, yeah.
And with the D2 model, which I'm not super familiar with, what can you tell us from that? Is that actually looking at like changes in lean body mass or amino acid content, or what is I know the advantage of that, if I remember correctly, is it allows you to do kind of more longer duration type things, but what do you actually learn from that method?
Yeah, so in short, why it's beneficial is if we now look at the infusion techniques that we do. So just to make it simple, we infuse labeled amino acids, and then over like some hours after, we can measure and calculate protein synthesis. That's of course great if you have people in the lab, and that we have them here internally. But if you want to say a bit more about longer term changes, let's say a couple of days or maybe a few weeks, of course, you cannot have people here on an infusion line always in the lab. And then we can use this technique D2O. So it's basically labeled water. And of course, we all drink water every day and get it from in our bodies via our foods. But this labeled water is a very cool technique, because if you ingest it, it kind of will be used by everything in our body essentially. And it's also very stable in the way that it is being used to produce alanine, which is an amino acid. And that amino acid we can see in our muscle if we for example, take a biopsy. And with that, we can then actually do the same thing by calculating muscle protein synthesis by seeing how much of the labeled alanine is being incorporated into muscle protein.
Very cool.
Very simplified.
And yeah, was there any estimations you could do off of that short 2-week study to see any change in muscle mass, or is the study just very short and you can't really put in? So one of the hard parts I've had, because one of the, I'd say at the top level practical question is, okay, so let's say I'm doing per most of the protocols, I'm going 20 minutes. I'm doing it immediately after training. I'm doing 8 degrees centigrade. I'm doing all the things that have been relatively well studied, that we have great data from your lab and others showing muscle protein synthesis changes, all these things. If I do that every day after training, at the end of a month, how much muscle is that costing me? Right? Is it costing me a quarter pound, half a pound, a pound? And I've had a very hard time giving any estimate based on the research, because there's different techniques. Like some of the changes you'll see, like cross-sectional fiber surface area, CSA changes, but it's hard to scale that up to an actual human. Even MRI is sometimes hard to extrapolate, because the average gym bro, that's usually the typical question. Is it costing me, like, and I don't know. I don't know if you have any estimate on, and I've had a very hard time coming up with anything.
Yeah, no, that makes sense. So just in short, of course, protein synthesis for people, okay, many people have heard of it, but indeed it's not like really something that you can like see or,
Right.
What I can say there, we found about 20 to 25% difference, which is a lot. That's just only acute 5 hours. The 2-week, we found 12%. It's still a lot if you think about it. But to make it very practical, I think then it's great to get back to that study from Australia, from Liam Roberts, where they actually found that if you look at quadriceps muscle mass, I think I have the numbers correct, but they focused on the quadriceps, and well, people know the quadriceps, and 12 weeks of resistance training, I believe they found in the control condition where they did active recovery after exercise. I think it was just like cycling at self-selected intensity. But they found 300 grams of gain. That's about a big steak, at least in the Netherlands. I'm not sure how it's in the, in the States, but it depends on where you go, where it's steak, I don't know, but like a big, let's say, big piece of beef. If you look at the group that did the cold water immersion, it was only 100 grams. So you still gain, of course, because you do resistance exercise, you do progressive training, but it's about 200 grams less. So that's also here. If I go to the supermarket, it's about like a steak, and it's a steak, and I'm only talking here about your quadriceps. I have to check, but that's I think a great paper to look into if you really want to have like some practical, more like takeaway from it. But that's what they found, and that's definitely very substantial. And certainly, if you want to gain mass for bodybuilding reasons or whatever.
Yeah, no, that's awesome. I have to go back and review that paper again. So that's super, super helpful.
Yeah, it's Jade Physiology. So
cool, awesome. And also, I just wanted to highlight, we had Jorn Promulan on here talking about a similar technique he used with the 100-gram bolus, and obviously Dr. Van Loon is the one who came up with this technique. And to me, it was super fascinating because like the stable isotope stuff, I find just utterly fascinating, but it's hard to extrapolate that per se to the average gym goer, where I think if you explain to them that, hey, we put this cool label in your protein and we track that protein of where it goes into the muscle. Again, this is highly overly simplified. But I think it allows you with a fair amount of estimates to get at the number the average gym bro wants, right? Hey, if I did this thing, like literally, how many more grams of muscle tissue am I going to have or not? Again, this is a very hypertrophy-centered discussion. And I also found it hilarious that some of the comments early on were, oh, well, why didn't you use casein that night? Or why did you use casein and not whey? Because they're like, oh, well, you read all the bodybuilding stuff. It says casein's a slow release. And then you talk to him and he's like, no, it was just economics. Like if we did this with whey, which I think you might have done at one point now, the cost would have been astronomical already. I think the first study they ran, he said it was like the most expensive protein like ever made, because it took
They had to get your own cow and they had to get the feed, and it took like, 2.5 years or something to even get the technique to be able to be used in a study.
Yeah. I think that's what you say now. Like people often don't realize, and it makes sense that they don't, which is also, of course, you can't.
Oh, of
They also
course,
don't
yeah.
realize what's happening in other jobs, but they don't realize what's happening behind like a paper that they see, and they often just read the abstract from and try to get some advice. But it's so much work and so much money and so much also pain oftentimes to get stuff done. But it's actually good that you say that that Jorn already explained the cow, because that's exactly this where we got the protein from that we also used in the cold water experiment. Yeah.
Yeah. No, I just always love highlighting that, because the pushback you always hear is that, oh, science takes forever. But I think people don't realize the amount of work that goes in, just to try to get that technique. And then, okay, now you have the technique, like you haven't even started your darn study yet. So now you got to run the study to use the technique. And it just takes a long time in a very slow, like stepwise fashion.
Yeah, absolutely.
Yeah. Any thoughts? I know we hear this like mythical, like, oh, if you wait the magical 5 hours, then this doesn't really matter. I haven't seen any studies that have looked at timing yet. And I understand why, right? Like, so like you mentioned, if you're looking at a new mechanism, you're probably going to take a very high stimulus to see, does this thing do anything at all? Because if it doesn't, one, it's boring, and journals don't like boring stuff. And then you wasted, 4 years of your life to find something. And then the peer reviewer will come back and say, oh, you numbnuts, it's 5 minutes of cold water. Why didn't you 20 minutes or some big stimulus? And then you do that study, and then everyone online is like, why'd you do 20 minutes?
That's right.
Right. But you want to see, like, if it didn't move the needle at some high stimulus, then you're like, we could try something else, but maybe there's not something here that we thought. Any thoughts on a window of time if you were to speculate, like if I wait X many hours or anything in that area?
I can, as you said, like by my knowledge, no studies, definitely not on protein synthesis.
I haven't seen any yet.
No. I always tell people, because it's only speculation that we can do, but what I do know, if you have a strong cooling protocol, and by that I mean, for example, you go into water for like 10 plus minutes, I think that even if you, let's say, wait for 5 hours, you still have some, I call it negative effect. The reason why I say that, why I think that, is that, of course, if you do a resistance training session, we know that the anabolic window, at least like that window by which your muscle is still sensitive to amino acids from the meals and still working on like stimulating protein synthesis, by simply then reducing the muscle temperature, and also if you have eaten in that period as well, the vasoconstriction, so you kind of impairing the delivery of those amino acids to the muscle, it's still going to have like some negative effect to that. I think, at least physiologically, that makes sense. So it's possible that it's not necessarily the same, let's say, attenuated response or impairment in response, but I still think it's not going to be beneficial. But having said that, I think a lot of people do, for example, cold showers, and they get their cooling from those kind of strategies. There, I would not expect much differences, as that's like, of course, just some water droplets, which are maybe cold, but it's not the same as it's like being in cold water for like a specific, like 10 plus minutes of time, for example. So it depends on the stimulus, but still, if it's a strong cooling stimulus, even if you do it later, I still at least think it's not going to be beneficial to you from this perspective. Again, I always have to be careful, because, you could have maybe some other benefits, but not for protein synthesis. So I still think if that's the goal, I would not recommend it for muscle mass gains and muscle strength gains, even if it's a bit later.
Awesome. Do you think on the end of the spectrum, I know you mentioned some of the studies have compared it to warmer water. Is warmer water or things that may increase perfusion give us a bump more above baseline than just protein? And related to that, I think there was a follow-up study, I can't remember, that came out this past year, showing that it was most likely blood flow being impaired in the cold water immersion that might be the main sort of mechanism of what's actually causing this drop in muscle protein synthesis.
Yeah, so that's also a study that we did here, where we found indeed that perfusion was like definitely one of the reasons to see this impairment in response. again, which makes sense. And I think it's the perfusion as well as the temperature drop that kind of together gives us, let's say, in at least from this perspective, an unfavorable environment. So that's true, that the mechanistic part of it. Regarding your first point with hot water immersion, that was our follow-up idea as well. Okay, cool. If cooling is not beneficial, what about if we heat up the muscle? So we did kind of very similar experiments, actually the same, but just we changed cooling one leg for 20 minutes into heating one leg for 20 minutes. And there we used 46 degrees Celsius, so very warm. I piloted it myself, and it was kind of the max what I could get for one leg. Don't even do this for your whole body. But I used that approach in the study, and then we actually did not see any difference at all. So to me, that at least how I interpret the data that we found was that, okay, it seems, and we know that if you do exercise, of course, you heat up your muscle already. You kind of see this big increase in blood flow towards the muscle, right? The muscle pump. It seems like that your body knows quite well what it needs to have this optimal environment for recovery. And by having, let's say, a relatively short heat exposure, this was again 20 minutes, didn't really further seem to benefit the process of muscle protein synthesis stimulation. So it's still a question to me, what if you do it for maybe a longer period of time with a different heating modality? But yeah, we didn't really see the increase in muscle protein synthesis if you would, let's say, take it practically if you would sit for 20 minutes in a jacuzzi following a resistance exercise training bout. But also it was not negative. So if people like it, I always tell, just go ahead and chill in the jacuzzi, but don't expect necessarily to see gains in your muscle mass from that.
Awesome. And one of my pet peeves, and I don't know if you would agree with this online, is that everybody seems to say that cold water immersion is anti-inflammatory, and it's the anti-inflammatory effect that's dropping muscle protein synthesis. But when I read most of your work and even some other earlier work that was done quite a while ago, all the data I've ever seen, with the exception of a couple data from cryo, which is just cold air, not necessarily cold water immersion, almost all of it shows that it's not anti-inflammatory, at least in healthy individuals. I'm not talking pathologies. Would you agree with that, or what is your take? Because I know you guys measured that directly.
Yeah, no, I do agree on that. That's what you always indeed see online. It's because of inflammation, blah, blah, blah. There is quite some studies that looked into plasma markers, inflammatory markers in the blood. But we, and also from Australia, we try to measure inflammatory markers in the muscle. And for example, we did mRNA expression. So I by no means say that that's giving you the whole picture, but at least gives some indication. And we did not see any, let's say, effect of cooling in terms of lowering that inflammatory response. So to me, it's definitely not that we can say with certainty that it's causing it because of the inflammatory response that people are always talking about. I really go always back to, I think that the main mechanisms are the drop in the temperature of the muscle, as well as the lowered perfusion. So the lower ability of delivering the nutrients to your muscle cells. And yeah, maybe future research will give more insights into inflammation, but at this point, I'm fully with you that I'm not convinced that we can say that there is the mechanism that we should look for.
Yeah. And you think the lower cooling is also, like you mentioned, changing maybe some enzymatic reactions that are also potentially having an effect then too?
Yeah, exactly. So you mean like the enzymatic response for like mTOR signaling and those?
Correct. Yes. Yeah.
Yeah. So I think that's indeed all like aligned with the fact if you reduce your muscle temperature, you reduce all this anabolic signaling. And this is one of the reasons, again, together with the lowered delivery in terms of by which we see this impairment in muscle protein synthesis. Yeah.
Any thoughts on, and you may not have looked at this, but any thoughts on cold water immersion after aerobic training? Because I've seen some mechanistic data that, may increase PGC1 alpha, and most of the data I've seen, my interpretation is I put maybe be beneficial for aerobic work, but it doesn't seem to be as negative for that. What are your thoughts?
True. So if you look at acute signaling responses, and if we focus for endurance more on PGC1 alpha, important for mitochondrial biogenesis or even vascular endothelial growth factor. So for capillarization, there we see that acutely there are quite some studies that show that this is upregulated, so higher than if you would not do cooling. So that gives some insight that maybe indeed you are able to make more mitochondria or maybe more capillaries, which is indeed beneficial for an endurance athlete. But if you look into like longer term studies, indeed so for example, if I go back to the resistance training study, we see clearly like reduced gains in muscle mass and strength, but for endurance, we don't really see much differences. So it's not necessarily negative, not necessarily positive there from an adaptation perspective. I would still love to see data and maybe if there's money at some point in the future to measure mitochondrial protein synthesis following endurance bout with this technique, that would be great to get more insights into that. But yeah, as you say, like acutely, there is some, okay, maybe it has some benefits even, but in the longer term, so far, there's not like clear evidence to show that it's giving you benefits following repeated endurance exercise bouts. Maybe your recovery as well then, Mike. So this is more the adaptation side. We also, of course, for endurance athletes, always focus a lot on glycogen. Definitely if you have back-to-back competitions like the Tour de France, for example, by which you need enough glycogen in the muscle to support your exercise sessions or your races. There we see that if you do a very strong cooling protocol, then you actually see also this impairment in the repletion of muscle protein synthesis. So you see lower increases in muscle protein synthesis compared to if you would not do this intense cooling protocol. Having said that, there is also data from the UK, from Liverpool, where they actually did only 10 minutes of water immersion for, I believe, 10 degrees Celsius. No, I think was 8 degrees Celsius for 10 minutes. They did not see any changes. So I think even there as well, there is like, if you have a strong cooling protocol, there you could even also impair your acute recovery process of specifically focusing on muscle glycogen synthesis. So even there, it's also like you have to be a bit cautious about what's the goal of my endurance bout and should I apply it or not.
Yeah, awesome. And related to that, I've seen some data on more, I guess I would bin it in more neuromuscular function, that some of the data shows performance might increase. Some of the data shows it doesn't increase. Some of the data shows it gets worse. It seems to be just an absolute mix of whatever. And I just wonder, I was talking to someone the other day about this too, like how much the placebo effect and nocebo effect affects this. Like, because you talk to some athletes and they're like, man, I love doing cold water immersion. Like, I swear it's the greatest thing I've ever done for my, recovery. Next athlete's like, that's the stupidest thing I've ever done. I hate it. My coach makes me do it. It's dumb. Like, I would love to see a study that used cold water immersion and literally just split them into like the placebo group who love cold water immersion and the nocebo group who just absolutely hate doing cold water immersion, and see if there's any difference between those two groups. My guess is I think there's a big difference, but again, I can't point to any studies on that.
So when you started talking about this, basically you give exactly the same kind of answer I would have given you. So it's funny about, so what we do a practical as well. And quite some years ago, there was, at least, let's say it kind of shifted over the years somewhat with people not believing as much anymore, at least the students here, maybe because of what they get taught here at the uni. But believing in cooling as a recovery strategy. And also now, if you look at like some measurements on the Biodex by which we measure MVCs, so let's say maximal muscle strength, we don't really see much differences anymore. I'm not saying that we saw big difference in the past, but it seems to be also, if we ask people now, they say, nah, I don't think it does much. And all my muscle soreness was not really changing between like either cooling or no cooling. And definitely this placebo effect. And there are studies showing that there is indeed a placebo effect on this recovery strategy. But I think that plays a big role as well. And yeah, you're right. Also, I'm quite puzzled by all the studies that looked into cooling following exercise, and some find benefits, some do not find benefits in terms of acute muscle performance. So yeah, even there are a lot of questions that we still could answer and could dive into. But yeah, I think such studies would be interesting to do.
Yeah. And I think even on the body comp, if I remember correct, I think Dr. Greg Haff did one. I want to say it was in soccer players. And if I remember right, I think they had a cooling arm and a warming arm. And I don't remember that they saw much difference in lean body mass or fat loss, or if I remember right, they didn't see much of any difference in it, like in terms of body comp. I don't know if you are familiar with that study.
Yeah. I think it's also with Shona Elson on that one. I think it was in elite rugby or basketball players.
Oh, maybe that's
weeks,
what it was. It was in pretty high level athletes. I remember that.
Yeah. I also think it was 15 minutes of either hot water immersion or cold water immersion or a control condition. And they used DEXA scanning and looked at whole body, total whole body lean mass, and indeed they didn't really see much differences. That's actually one article I always highlight as well if I talk to this to our master students here and saying, okay, there's like, in the longer term 12 weeks, we see like some impairments if your main goal is gains in muscle mass. But, if you do it for, let's say, a shorter period in your overall training program, by which you also do other types of training sessions, it's not something that you have to be like, if you have sitting like a water bath for once and think, oh, damn, now I have ruined everything for the next. It's kind of definitely more context specific. And I think that study, at least for me, shows that nicely. Would be interesting also. That was with DEXA scan. I would love to see what happens in the muscle because you cannot really measure that with DEXA, but still it gives some interesting indication on that.
Yeah, that was my thought too. Like if you did that exact same study and you did MRI or something that's a little bit more in depth than DEXA, and DEXA is good, but something that has a little bit finer limits of difference, like would you see a difference? I don't know. On some days I'm like, yes. And other days I'm like, I don't know.
Yeah, no, exactly. I actually did also comparisons on like DEXA and MRI scanning, and it really also did. If you look, for example, at like tissues atrophy, we found that if you have people very well standardized for 2 weeks in a bed, we know you lose a lot of muscle mass. But we can actually also measure it with a DEXA scan, like a very similar decline in that sense than leg lean mass. So indeed, it's definitely a useful technique, and it's depending on the question and how precise maybe you need to have answers on what you want to measure, if you can apply it or not. But it definitely gives some interesting insights.
Yeah,
and then much more easy to do than an MRI scan.
Oh, by far, and way cheaper. Not that DEXA is cheap, but compared to an MRI, it's cheap.
It's very cheap. Yeah.
And again, you could argue with that study that there wasn't this huge massive difference, and DEXA is good enough for what the question you're trying to answer. So
no, absolutely, definitely is a very interesting insight from that study that we can take away.
And do you think cold water immersion is magical for fat loss?
No, that's also sometimes that I've heard people talking about. No, what did they even say? I actually forgot. Was maybe with the cold shock response or something that everything gets activated and all of that stuff. No, I don't see how. The only thing, maybe it could have like a very small effect if you put people in like maybe cold suits or something by which they shiver, right? They have all these contractions and therefore you expend something. But if you compare to people like that actually do like, I would now call it the optimal way of fat loss and watch your diet carefully and together with exercise, then I think it's very minor. And I don't expect, this is definitely not a magical way to lose fat. Definitely you have to, first of all, look into your diet and eat less than what you would expend on a daily basis for a prolonged period of time to get to see what's happening or to actually lose fat.
Yeah, that's what I got from the literature too, because I initially started pulling all this years ago, and my first thought was, I was cautiously optimistic. And I'm like, okay, like if you do the physics and you do the thermodynamics, like it might kind of work out. And then you start looking at all the research and basically no, like the only study I could find was the one you referred to, was super old study, maybe 50, 60 years ago from the military, where they stuck people in a pair of shorts, like literally in a freezer, and they left them in there for, I don't know how long. It was hours. And they were just sitting there, just shivering. And they did see some fat loss in that study, but no one's going to do that. That is absolutely horrible.
Yeah.
Nor would I recommend anybody do
I
that.
mean, if maybe I haven't really thought about this now, but if you have people that for some reason cannot do exercise and they still need to lose some body fat, then maybe like some such extreme strategies could help something. But again, if you look at the healthy person that can do like, watch their diet and do exercise, then it's very minor at best, I would say.
Yeah. And if anyone's done enough cold water immersion to get to the point where your teeth are chattering and shivering uncontrollably, which again, I would not recommend anybody do this. I may have tested that in my garage freezer full of water. It is miserable. Not only is it potentially bad for your health, like you feel miserable for hours after. Like you just cannot physically get warm. Like you can't focus on anything. Even if that was a thing that ripped fat off my body, I still don't think I would do it.
Yeah, no, that's another thing. Yeah.
Awesome. Any other thoughts on cold water immersion or stuff you see going around that you wanted to comment on?
So yeah, I think what I still find interesting is to what I already mentioned, look more at maybe at the endurance side of things. So if there are benefits there, that's still some questions that I have. I think for resistance training, I mean, we are scientists, so we're always interested to get more data on like similar topics. But to me, it shows quite nicely that it lines up that it's not going to give you the benefits of gaining muscle mass. So, but like for the endurance side of things, I'm still interested in some questions that I would like to be seen answered. And then maybe not so much the cooling, because cooling you can also think about other strategies like the cryo saunas, the cryo chambers. That's like very popular now, and a lot of sports teams that have a lot of money, they have these things installed at their facilities. But I think heating is also something I'm still very interested in to see like, hey, what happens with sauna? What happens with if you go actually for in hot water, do hot water immersion, go into a jacuzzi, or even these devices by which you can do very localized heating, which is something you can do with diathermy, for example. I still think there is quite some interest in seeing like, hey, what's happening with these strategies in terms of muscle physiology, what is changing or not, and maybe how could we use such tools to improve, muscle mass or muscle strength, or just general health in general. Those are still, I think, quite some questions that can still be answered, and that's more maybe not so much just the cooling, but just cooling and heating or just temperature in general. It's still very interesting to me.
Yeah. The one thing I've done, which I call like poor man's contrast therapy, if you only have cold water immersion, you live in a hot environment, and this is more of a eustress model. So I'll drag my rower out in the middle of the street, do a bunch of rowing on that, especially on hot temperature days. And then I'll get in the cold water immersion for maybe 1 or 2 minutes, dry off, and then I'll go back and do the rower again. So I'll go do intervals back and forth. And what I found was the cold water immersion to basically dump all the heat that I generated. My performance on the following intervals was actually quite a bit better. I don't do it a lot because, in all honesty, like, it sounds stupid, but like toweling all the way off and putting all your clothes back on, it just gets to be kind of a pain in the ass to do. But the handful of times I did it, it was quite interesting of how much of a difference that made. And that kind of makes sense looking at the literature that, if you can't dump heat, that is probably going to be a limit to your exercise performance. I don't think there's going to be any benefit to that if you're in a thermoneutral or probably not a hot environment.
No, if you can get rid of the heat from your environment, indeed, you're right. But exactly, if it's already very warm and also humid outside, and you even like with sweating and the evaporation from which you have difficulties to get rid of the heat, then that could indeed be like, or a cooling vest you see people applying sometimes, or like you even have these gloves that you see sometimes that people put like cold water around to kind of help your body to get rid of body heat and therefore still be able to perform for longer in like warm environments. Yeah.
Any thoughts on that cool mitt? Like I've tracked that thing for, God, I first saw an article on it 14 years ago, I think, in Wired magazine. And they were saying like, oh my God, my endurance went crazy. And then I checked on it and someone did file a patent. And then someone else sold the patent. I think a university had the patent for a while, and now supposedly somebody else has a patent. And it's basically a cooling device under vacuum through the hand. And they claim that even at like thermal neutral type environments, that because muscle activation requires heat, that if you can cool it, that the heat dissipation will make a big difference in performance. But I can't find hardly any literature that's been reviewed. I can't find anyone who's used it and tested it. It just seems like this mythical thing that keeps showing up every few years with these crazy claims that I can't verify. I want it to be true, but I don't know. Any thoughts?
Yeah, I'm not 100% sure if this is related to the cooling glove, but I even once read this also a long time ago that there was even like, maybe it was even like a news article based on a scientific article. Maybe it was even in the discussion of the article, but they said like that the gains that you could make by your exercise were like the same as using anabolic steroids. In terms of like doing pull-ups or something, if I recall.
So is pull-ups what they used?
Yeah.
Yeah.
I'm like, yeah, you guess. But you know, I mean, if you're able to help your body by getting rid of heat in a warm, humid environment, then maybe you could do some more pull-ups. That to me makes some sense. At least if you do it for more prolonged types of exercise sessions. But is it more like beneficial than other ways of cooling? I'm not sure. Maybe depending on the type of activity you do, like you go, of course, if you now you can go into so many different topics. But for example, sprinting, you don't want to go into like cooling your legs off because you need warm legs to be able to sprint, and it's not even like a limitation necessarily like the heat that you build up for a very short period of time. So. Yeah, I think it's also something I recall. I haven't looked into this for a long time. I'm very interested in it, and I think water or like hand cooling can have a place as a way of a cooling strategy. But being it something magical, doubt.
Yeah, or I'll tell you, this is about 1 or 2 years ago. My buddy Coach Cal Deitz had cold soda cans he was testing with his athletes as a way of dissipating heat. So I took my freezer with the cold water immersion and may have put cans of soda in there. And in the summer, use that to just basically hold them in between sets to see if I noticed a difference. I thought, I don't know, maybe this is like the $2 version of a $1,000 device. It seemed to help, but I couldn't notice like a huge difference. And then, the people who sell the device would argue that, well, because it's not under vacuum, you've got local vasoconstriction and you're not really getting the heat dissipation that you want, would be their argument. And I don't know, I guess if people want to try it, that's like a $2 way they could try something. Let us know if there's any difference.
No, and even like putting like a hand in cold water for a longer period of time. And I have heard people, and also that it could maybe be beneficial again in some settings, but like to call something magical, I'm like always skeptical.
Yeah. And if you also have a pain response too of sticking your hands in cold water, and that can definitely inhibit performance too. So that it could go both directions depending upon. I could give you some physiologic mechanism of how it's the worst thing to do for your performance. I could give you a mechanism that it's the best thing to do, and it's probably neither.
Yeah.
Cool. Last question on the cold water stuff. I appreciate all of this. It's super interesting. Any thoughts about doing it before exercise? It seems like that's sort of the new trend. And I talked to Dr. Tom from Morosco Forge about this too. And, he cited some older literature that there's these increases in testosterone if you're doing it before exercise. And we do know there is increases in epinephrine, norepinephrine, and dopamine. There's one study that's been published on that. Whether that shows up chronically over time is probably up for debate. And obviously you'd want to warm back up so you're not going into exercise completely cold, because we know that can affect performance. But any thoughts about doing it before like a lifting exercise?
Yeah, I think again, indeed, you don't want to have your muscles necessarily cold.
Right.
But having said that, if the environment you're doing your exercise in is very warm and let's say also humid, so more like the extreme conditions by which it's difficult for your body to get rid of the heat, And then there are some studies that nicely show that if you do pre-cooling, that it can help you performing.
Yep.
But again, it depends on the type of activity. If you do a sprint, it's not really, you don't want to cool your body and certainly not your leg muscles. So then I would say don't do it. And even there are studies, by my knowledge, that actually showed that there was also impairments in that performance. But if you, let's say, okay, I'm going to go for like a 5-hour ride on the bike, as an example, and it's, it's very warm outside. You also see like athletes, having cooling vests or like do some kind of pre-cooling measurements. In those situations, it could make sense to improve that performance, or at least start off your body not already too warm, by which you impair your performance quicker during exercise. For weightlifting, I think it also depends on where you're doing it. I think in the USA, you guys have some beautiful beaches where you can do weightlifting. If it's warm there, then maybe you could even have some benefits. But the gym that I go to, like you're inside, it's air conditioned, no benefit of pre-cooling on that. So I think it's really dependent on what's the limiting factor. And if that's becoming that your body cannot get rid of the heat, then there are settings or situations and contexts by which I think it could have some benefits. Yeah, but not always.
Cool. Awesome. We transition a little bit into different things related to glycogen resynthesis, and I know you've done a lot of work on that. We know temperature can affect these, correct? You had mentioned that if you're staying cold, that's going to affect how well your body can basically stuff these carbohydrates back into muscle. And I assume that's probably just due to enzymatic changes again because of the colder temperature.
Yeah, and also the delivery again of the carbohydrates.
The blood flow is going to be less too, so your perfusion is going to be lower.
Yeah, exactly.
Then you also talked about using different types of carbohydrates. I think using like fructose and some other forms. You want to explain a little bit of the theory behind that? And there's been a couple of very cool studies on that have shown that to be beneficial.
Yeah, sure. So that was actually one of the first studies that I was doing. So just again, if we go to glycogen repletion following exercise, and this is of course can be relevant for all athletes, intermittent, even sometimes resistance, depending on your training program, etc. But it's mostly used and really focused on for endurance athletes. Again, to put it in context, things like Tour de France, they have a very limited recovery time between two stage races, and they want to really increase glycogen repletion as quick as possible in the muscle and actually also in the liver, because the liver supplies your muscle during exercise with carbohydrates by breaking down the glycogen stored locally in the liver will be transported to the muscle. And then what we did is we wanted to know, okay, what if we look at different types of carbohydrates that we give following exercise? And we not only measure the muscle, because muscle, since the 60s, and a lot of Scandinavian researchers and a lot of people now from all over the world take a lot of muscle biopsies, including in our lab, to measure muscle glycogen. But with nice techniques, we can also measure it in the liver. We know the liver is important. And again, we wanted to combine those two together. And what we did, we provided participants, so cyclists, following a depleting bout of exercise on the bike, we provided them with either glucose or with sucrose. And sucrose is basically 50-50 of glucose and fructose. So those are two different monosaccharides. And the idea why we wanted to test those two was that from like decades ago, we have like mostly focused on providing glucose or glucose polymers in recovery or during exercise. And over the last, already quite some years now, but there's more focus on like looking into different types of carbohydrates, such as glucose and fructose. And this fructose component is interesting because it's really used and metabolized predominantly in the liver. And we wanted to know if you provide both of those, so glucose and fructose, is that better for liver glycogen repletion compared to just glucose? So we did that study, 5-hour recovery period. I've talked a lot now already, Mike, I'm sorry. But
You're good.
5-hour recovery period, and then providing in that study 1.5 gram per kilogram body mass per hour of either glucose or sucrose. And we found that for muscle, it didn't matter. So you saw the increase in glycogen resynthesis, as you would expect, because you give the substrates to be used to build new glycogen there. But for the liver, we saw a big change. It was almost doubling. So by having more fructose in your post-exercise meals, you kind of can support your liver more than if you would say or predominantly stick to glucose-based meals. So that was the first study by which clearly we showed that was beneficial for the liver. And there's actually studies before it that showed the same thing. But they only measured the liver. So we now measured muscle and liver. And now we found, okay, muscle doesn't matter, liver it does. So if you look at overall total body glycogen repletion, it would be great to add some fructose in your diet. And that was kind of the first. And now I'm like also doing more studies on like looking at how quickly can the liver replenish. A recent article published. We also provided sucrose over the first 6 hours. And we actually also then measured the whole 12-hour period in terms of muscle and liver glycogen repletion. And we kind of found in that study, and maybe just again to explain the design a little bit. So we scanned people before and after a bleeding bout or like an exhausted bout of exercise on the bike. And I say scan because with scan, we can non-invasively measure glycogen in liver and the muscle. And then afterwards, we looked for 12 hours. At 6 hours and 12 hours, we scanned them again, and we either gave them absolutely nothing. So that was they were really fast for like a long period of time. Or we provided like the first 6 hours sucrose-based drinks. And then the last 6 hour window, we provided 2 carbohydrate meals to make it a bit more practical. And we actually found that muscle was in those, let's say, optimal carbohydrate conditions, not replenished within 12 hours. Not very surprising because previous studies have shown you probably need around 24 hours for that. But the liver was already like above baseline, so before the cycling within 6 hours. So again, showing that if you give sucrose, we didn't compare it to glucose there, but if you give sucrose or you give a mix of glucose or fructose, that it's really beneficial to have like a big stimulus on stimulating glycogen repletion in your liver. And again, to make it practical in the long term, you want in those settings, you want to have high glycogen availability in muscle and in liver. So that's very beneficial to focus on different types of carbohydrates.
Oh, that's cool. And this would be obviously super important for people doing back-to-back exercise, or they're doing extremely intense, demanding exercise one day and they got to come back and do it again the next day, correct?
Exactly. So if you have to train twice a day, or let's say, okay, tomorrow is an important match and then the day after again, then it's really important. If you say I'm going to do a marathon run and like for the week after, I'm like more, not maybe some, let's say, low intensity training session, but nothing important, then it's less relevant to focus really on those different types of carbs. So you can just have like some good meals with enough carbohydrates to restore it. But for indeed the back-to-back sessions is very important.
What are your thoughts about that? Seems to be in the, I'd say more elite endurance world, this pushing of how many grams of carbohydrates can we get in per hour during exercise? It seems to be like this escalation war of, it used to be like, 60, and then, oh no, we went over 100 and now it's like 150. And it seems like every time I turn around, someone else is claiming that they're at like the next highest number.
Yeah. It seems to be a thing now. That's actually interesting because it relates also to the fructose. What I said is like,
right.
As you say, like in the days, it was always like the max was 60 grams per hour during exercise, and that was a glucose. Because if you get higher amounts, we didn't measure a day because back then I wasn't in science. I wasn't even old enough. But they found that, you can give more glucose, but it didn't benefit you because you didn't oxidize, you didn't use it. But then, and this is all nice work from Master Eukenrep back then, he was also in Maastricht doing his PhD in the past. But they kind of figured out like, hey, if we combine glucose with fructose, you can actually increase that amount that you can oxidize during exercise. And then it led to like, we could actually go to 90 grams per hour if you mix. Of course, then it's still important to look if you need it during exercise, depending on the intensity, the duration, etc. So that was for long, like the advice, if it's like longer intensity or like higher intensity for long duration, go for 90 grams per hour. Now there are studies showing that 120 grams per hour could even lead to a bit higher, or actually quite some higher oxidation rates. The question still is that going to benefit your performance? They found like no further sparing on endogenous glycogen stores. So that doesn't really seem to be the mechanism, but yes, you can oxidize more. And as you said, like now in practice, they even go higher. So I also work with Team Visma Lease Bike, professional cycling team, and they are even going higher, some of these riders. And, it's a matter of like carefully seeing how do they respond, what do they say, and a lot of it now is like some of them just try to increase it, and as you said, like I've read stories about triathletes that even go, I think, even beyond 200 grams per hour. I'm like,
right? I was like, what?
Could you? How? And if so, is it going to benefit? Can you tolerate more, or can you actually use more? Let's say I'm a bit skeptical on these high numbers. I'm definitely open-minded because I think we should be, but we are definitely not there with science to say like, oh yeah, that makes complete sense. And we need definitely more research to see if that's even going to benefit you or not. And then also, the placebo effect can play a role. If you think, I can actually ingest more and it feels good, I'm performing better. I don't know if it's really benefiting them physiologically or not. But definitely interesting to research this more. And I think one more point that is important in practice is definitely if you think about, for example, Tour de France, you can increase more and more during the race. But it's really important that we figure out if we can use it as well, because if it's just a matter of toleration and not using it, you kind of take away some room for like a recovery meal, for example, which is also really important, as we discussed, about the glycogen that you want to restore. So there's a lot of factors that people they should take into account before just saying like, let's just try to get us in as much as possible for trying, because it can actually be detrimental for other meals that you also want to use or need to use for other reasons, like recovery.
Yeah. I mean, if you look at the data from even some of the testing that's been done with metabolic cart, and you look and say, okay, even at high intensities, you're 100% or close to 100%, carbohydrate oxidation. To me, the numbers just don't add up unless there's a bunch of freaks who just haven't been tested, but you can kind of infer it based off of their power output as to theoretically about where they would be. And to me, like these 180, 200, like the math just doesn't add up to me unless there's some other central mechanism going on where you're sensing carbohydrates coming in. So it's the whole, central governor theory that maybe you've got a little bit less of that, and your perception is like, I'm good to go, even though my output isn't. And I don't know anymore.
No, I think we need the data. We should study and just see if it has benefits. And I fully agree on that. Yep.
Awesome. As we wrap up, like, what are some recent studies you've done or other studies you've got coming up that you're like super interested in?
So actually, like the last few days, I was now impressed, but published an article now where we looked into, so it's now online, where we looked into breakfast and just look at if the breakfast that, in this case, also well-trained cyclists take in, how much of that would lead to more liver glycogen. Because, of course, if we all are like a well-known strategy is carbohydrate loading to kind of make sure your muscles are loaded in the day or days before leading up to exercise. But of course, also people say, okay, then you have your overnight. If you do the day before, you do loading, but then you have your overnight period by which your liver glycogen is going to be reduced because, of course, you need to have energy for the brain and erythrocytes, etc. That's required that glucose. So liver glycogen is reduced, and then the advice is always, okay, have a breakfast containing sufficient carbs to kind of top up that liver glycogen that you need to optimize then your subsequent performance. That makes sense, and there are studies showing that liver glycogen concentrations are increased. We measure that as well. But what's interesting and what's fascinating to me is that if you measure liver volume, in the morning and then in the early afternoon, it actually reduces in size. And we found that in this study as well. So yes, you see that over And again, maybe just to design briefly, we give 3 grams of carbohydrate per kilogram body mass. And then we measured for 3 hours postprandially. So we wait for 3 hours. And before and after, we again took the scan to measure liver and muscle glycogen. And we found again, liver glycogen concentration increased, but the liver volume declines. And if you then look at the total storage, there was actually no change. So you don't really store necessarily more liver glycogen in grams. You do, and we didn't have a control condition there, but I do expect that you don't see the decline that you would otherwise see if you would remain fasted. But you kind of do not see the top up that we always think happened because of that changes in liver volume. And it seems to be very consistent, even if you eat, that you still probably a circadian effect, but that your liver or your body decides that your liver, like during the day, as you wake up, it actually reduces a bit in size and then it will come back up again. But that's kind of a fascinating thing that I found. And that's actually quite interesting that we don't really see that the grams of glycogen in the liver are actually increased following a big breakfast with carbohydrates. So that was something very recent. Now you asked me the question. At the moment, a lot of things with the scan. I really like the MR scan because you can do great measures on body composition, muscle mass, and fat in different locations. So do research on that. I also did research on bodybuilders to look at what happens to their muscle volume, but also organ volumes. That's not published yet. And also now like doing more work with like non-invasive ways. So again, with MR, but then MRS, so magnetic resonance, not imaging, but spectroscopy to look more into metabolites and change with exercise, with nutrition and all of these things. So still a lot going on.
Well, that's awesome. Is there anything you can say that's public about the bodybuilder study, or we just have to wait and read it once it's out?
Yeah, that's hopefully won't take necessarily very long, but
Cool.
I cannot share too much. I think from the muscle volume perspective, it's kind of expected, but some cool stuff on the organs. But what we essentially did is we had like control conditions. So let's say recreationally active males. Then we took natural bodybuilders and also bodybuilders using appearance and performance enhancing drugs. So amongst others, anabolic steroids. And just look at what are the differences there when we scan them and do a lot of measurement. So that's some cool stuff that will come out as well. But I will share it to you, Mike, as soon as I'm.
Yeah, no, that's great.
Share more on
that's super interesting because they've had that one published study looking at, I think it was a case study on a single bodybuilder. Maybe they had a couple that showed hyperplasia after many years of training and use of PEDs. Which was, I think, one of the first times that hyperplasia had been demonstrated in humans. I don't want to say conclusively, but at least in terms of a case report, which was pretty interesting.
Yeah, even there's so much to learn. And yeah, it makes complete sense, of course, but somebody's like, oh, it will be cool to do these and these studies and give like, I'm certain that I can get a lot of guys interested in like, hey, let's give you some steroids for like prolonged period of time and measure you very carefully. But yeah, of course, ethical reasons restrict us in doing these things. So we are like stuck to people that are already doing it by themselves, which to some extent makes sense. But it's interesting to dive more into what's happening there, exactly in the muscle cells, and yeah, a lot to learn still.
Yeah, I feel like a lot of those studies just haven't been done. I mean, was it Bazin, I think, that did a lot of those in the 90s?
Yeah.
He had a couple of studies, and since then, like, it's just been like, yeah, you can find stuff in health areas. You could find just kind of anecdotal stuff, but in terms of like, hardcore meatheads, there's just not much.
No, exactly. I think back in the days in Maastricht, again, before I was there, they did some studies on steroids, also self-reported, but also they sometimes injected for like some weeks. And ever since I'm in the lab here with Luc van Loon that you already mentioned, there was a study where we could inject a single bolus of nandrolone, but that was in like tissues because then you can kind of more argue it could be beneficial if people are injured or like lose a lot of muscle to kind of maybe see if we can help them. It was from, let's say, I think for a lot of bodybuilders, a relatively low dose, but yeah, it's very difficult. You cannot really do many of these studies with like a lot of restrictions on that.
Yeah,
So
that's cool. Yeah, last question. If you were to give a rapid fire, like your top 4 things the average gym goer should know about cold water immersion, what would you say?
So the guys that or girls go to the gym, like for resistance training,
Mm-hmm. Yep.
or just general? Um, for cold water immersion, I would maybe let's say cooling. If you really like
Sure.
cooling for specific reasons. So people I know said like, could I take a cold shower? Yeah, of course you can take a cold shower. Maybe it's some people report. I don't know if if there's solid backup for this at the moment, but they report to sleep better. By all means, if you have ways by which you can sleep better, we know sleep is so important for recovery, so you should do it. But then if you say like, I want to make gains for strength and mass, and I'm considering cold water immersion, like an intense protocol, I would say don't do it because it's not going to help you from that perspective. Maybe if you go, is it called Muscle Beach? Is it right, Mike? And
Yeah, Venice.
if you want to train there and it's very warm and humid outside, I don't know what the temperature's there, but I suspect it's warm there. Then maybe before you could do like pre-cooling as a strategy. But like it's a bit context dependent. I think mostly if you look at cold water immersion as a post-exercise recovery strategy, I would say don't do it. The goal is to gain muscle mass and muscle strength.
Awesome. Cool. Well, thank you so much for all your time. Where can people find out more about you if you want to be found outside of the lab?
I don't, not, well, yeah, I share most of the work on my LinkedIn page these days, sometimes still on X, formerly Twitter, sometimes on Instagram as well. But it's, Mike, it's as an academic with also teaching and research is so busy that I am active on it, but let's say passively active. It's just sometimes you watch. It's not like that I'm a big social media guy. I do have the accounts. I do share my research, so people can find me there. Just type in my name, and you'll be able to find me. And of course, if there would be specific questions, you can always email me as well. You can also find everything on the Maastricht University website in terms of my email address, etc. So I will be, you can find me relatively easy. So that's the good news, I think, if you even want to find me.
Yeah, I always feel go back and forth even asking researchers that question because part of me is like, I don't want to do anything if they're looking to get more exposure to hamper their exposure. And then the other like more sinister side of me is like, no, don't pester these people. They're doing like really cool research. Like just let them do all the research.
No, so I will be honest. Sometimes people may ask like so much and like, yeah, it's not possible, but everyone can really ask questions all the time. That's also, I think, what's cool about what we do. We love to share, what we did now today. We talked about research stuff we're fascinated about. So definitely ask questions. I'm always open to that. And maybe another reason, if you want to find me or Mike, you can always ask Dave Church. He is like a good person to contact as well, and he also has all my contact details. So he can be
any questions at all. Send them to DC. Cool. Awesome. Well, thank you so much. I really appreciate all your time. This was great. Thank you so much.
Thank you for having me, Mike.
Thank you so much for listening to the podcast. Huge thanks, Dr. Fuchs, for all of the amazing research he's done. I do reference a lot of it in the Physiologic Flexibility Cert. That'll be open in probably around April-ish of this year. Really, really great stuff that he's done in the lab over there at Maastricht, and just a wealth of great information. And it's always wonderful to talk to the people who are doing the direct research and get all the info directly from them. So if you enjoyed this podcast, you'll enjoy my daily Fitness Insider newsletter. Go to MikeTNelson.com. You can hop onto the newsletter completely free. And we do have the Flex Diet Cert opening again February 9th through the 16th of 2026. We'll have some cool fast action bonuses and a bunch of other stuff. Those will go out first to the newsletter. So hop on there if you're interested. And I've got a ton of more information about the Flex Diet Cert over there, which is a flexible system using metabolic flexibility, primarily for the nutrition side. But we do talk about a little bit of recovery, NEAT, fasting, micronutrition, some basic exercise, and then, of course, proteins, fats, carbohydrates, and much more. So hop onto the newsletter, MikeTNelson.com. And thank you so much for listening. We really appreciate it. If you can do us a favor by sending this to someone you think may enjoy the podcast, do the all wonderful things of give us some stars, drop a review, download, subscribe, all that great stuff helps us with the old algorithms to keep getting amazing guests like this and a better distribution. So thank you so much. Really appreciate it. Talk to you next week.
Well, that's talent. An opera singer who tap dances and sings cowboy songs. I wonder if there's anything she isn't good at. Yes? Choosing what show to be on.
This podcast is for informational purposes only. The podcast is not intended as a substitute for professional medical advice, diagnosis, or treatment. You should not use the information on the podcast for diagnosing or treating a health problem or disease or prescribing any medication or other treatment. Always seek the advice of your physician or other qualified health provider before taking any medication or nutritional supplement, and with any questions you may have regarding a medical condition. Never disregard professional medical advice or delay in seeking it because of something you have heard on this or any other podcast. Reliance on the podcast is solely at your own risk. Information provided on the podcast does not create a doctor-patient relationship between you and any of the health professionals affiliated with our podcast. Information and statements regarding dietary supplements are not intended to diagnose, treat, cure, or prevent any disease. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to therein. If you think you have a medical problem, consult a licensed physician.